And here we have 1 marks questions, and in this question we are given 3 angles of a quadrilateral are equal and we are asked to say whether it is a parallelogram. So let's work out the problem. Here we take ABCD is a quadrilateral. In this question we are given 3 angles of quadrilateral are equal. Therefore we assume angle A, angle B and angle C are equal and they are equal to x degrees. And we know that sum of the interior angles of any quadrilateral is equal to 360 degrees. Therefore we get 3x plus angle D is equal to 360 degrees. From this, by using trial and error method, we have to find the values of x and d. Here the value of x is 80 degree and then its corresponding angle D value is 120 degrees. And we have angle A 80 degrees and angle B is 80 degrees. Angle C is also 80 degrees and angle D is 120 degrees. From this we can say that ABCD is not a parallelogram. Why it is not a parallelogram? It is because if we consider the sum of any two adjacent angles, let angle A and angle B, their sum is equal to 160 degrees. From the properties of parallelogram, sum of adjacent angles is 180 degrees. Since here the sum is not equal to 180 degrees, we say that ABCD is not a parallelogram. Therefore, it is not necessary to have this quadrilateral a parallelogram. Let's move to the next question. In this question, we have to find the coordinates of the points where the graph 2x plus 3y is equal to 6 meets the x-axis. Here we take x and y-axis and we assume this is the graph of linear equation 2x plus 3y is equal to 6. According to the question, we have to find out the points at which the graph meets x and y axis. We take A and B are the 2 points where the graph meet at x axis and y axis. To find these coordinates, and we know that the distance of point A from x axis is 0. Therefore, its y coordinate must be 0 and we don't know its x coordinate. We find its x coordinate by using this equation. Similarly, here B lies on y axis. The distance of this point from y axis is 0. That means its x coordinate is 0 and we have to find its corresponding y coordinate. So let's work out the problem. Here by substituting x is equal to 0, we get B, that is point B. Here we have the equation 2x plus 3y is equal to 0. On substituting x is equal to 0, we have 2 times 0 plus 3y is equal to 6. That is y is equal to 2. Therefore, 0, 2 is the point where the graph 2x plus 3y is equal to 6 cuts y-axis. Similarly, to find point A, that is the point on x-axis, we take y-coordinate 0. And here we have the equation 2x plus 3y is equal to 0. 2x plus 3y is equal to 6. Let's substitute it here. And here we have 2x plus 3 times 0 is equal to 6. That means the value of x is 3. Therefore, 3, 0 is the point where the graph of the equation 2x plus 3y is equal to 6 cuts x-axis. And this completes our solution. Let's move to the next question. Here we have to find the lateral surface area of a solid cylinder, and its diameter is 50 centimeters and height is 3.5 meters. So let's work out the problem. Here we take the cylinder Let this be the cylinder and its diameter is 50 centimeters and its height is 3.5 meters. That means we are given the value of diameter and height, and these two are in centimeters and meters, so we have to convert in either centimeters or meters. First of all, we note down the given data, that is height of cylinder is small h, it is equal to 3.5 meters. Similarly, diameter, that is the diameter of base circle, which is 2 times its radius, and it is equal to 50 centimeters. And we know that 50 centimeters is 0.5 meters. Therefore, the value of R is 0.25 meters. By using these two, we can find the lateral surface area of the solid cylinder. Here the lateral surface area of this cylinder means its curved surface area. How we get its curved surface area? Here we have the circle and its circumference is 2 pi r, and we have height total h. Therefore 2 pi r times h is the lateral surface area of this cylinder. Let's substitute their values. We have the value of pi, which is 22/7, and radius is 0.25 meters and height is 3.5 meters. If you look at a numerator and denominator, 7 is common factor and 7 goes in 0.5 times, and we get the product of numerator, that is 2 times 22 times 2.5 times 0.5 is 5.5, and here we have meter into meter, which is meter square. Therefore, lateral surface area of this cylinder is 5.5 meter square. And this completes our solution. Let's move to the next question. Here we have AOB is a diameter of a circle and C is any point on the circle. We have to say whether square of AC plus square of BC is equal to AB square. We have to say it is whether true or not. So let's work out the problem. If AOB is diameter of a circle, then O is a center, and if we take C is any point on the circle, we will get a triangle ABC. Let's draw the figure. And here we have ABC is a triangle, and here AB is the diameter. So we know that angle in semicircle is right angle. Therefore, angle C is right angle. We say that triangle ABC is a right angle triangle. In this right angle triangle, from Pythagoras law, square of hypotenuse, here hypotenuse is AB. So square of hypotenuse is equal to sum of the square of other two sides. Here we have AC is one side and BC is other side. Therefore, it is true, and we say that the given statement is true. How we got this condition? It is by Pythagoras law. And this completes our solution. Let's move to the next question. Here we are given the angles of a quadrilateral are in the ratio 2:3:5:8, and we have to find the angles of the quadrilateral. So let's work out the problem. If we take the ratio, that is the ratio of angles of quadrilateral is 2:3:5:8. And here let x be the common factor, then we have angles of quadrilateral, and they are 2x, 3x, 5x and 8x. Here we have to find the value of x. So how we get the value of x? We know that sum of interior angles of any quadrilateral is equal to 90 degrees. Here sum of interior angles in any quadrilateral is 360 degrees. Therefore 2x plus 3x plus 5x plus 8x is equal to 360 degrees. And on left hand side, the sum is equal to 18x and it is equal to 360 degrees. Therefore, the value of x is 20 degrees. Let us substitute these values and find the individual values. Here 2 times x is 40 degrees and 3 times x is 60 degrees and 5 times x is 100 degrees. 8 times x is 160 degrees. Therefore, 40 degrees, 60 degrees, 100 degrees and 160 degrees are the angles of quadrilateral. And this completes our solution. Let's move to the next question. Here we have to find the value of p from the equation 3x plus 4y is equal to phi. Here p is unknown and we are given condition this. One of the solution of this equation is x is equal to 2 and y is equal to 1. Let's work out the problem. Here for x is equal to 2 and y is equal to 1, the given equation is true. Therefore, we take the equation 3x plus 4y is equal to p and substitute the values of x and y. On substituting, we get 3 times x, which is 2, plus 4 times y, which is 1, that is, and it is equal to p. Therefore, the value of p is 3 times 2, which is 6 plus 4, it is equal to 10. Therefore, the value of unknown p is 10. This completes our solution. Let's move to the next question. Here, if the point 2, 1 upon 2 lies on the graph of the equation 2x is equal to ax minus y, we have to find the value of unknown a. Let's work out the problem. Here the given equation is 2y is equal to ax minus y and 2, 1 upon 2 lies on the graph, that is 2, 1 upon 2 is the solution of this equation. So for the values of x and y, the given equation is true. On substituting the value of x and y, we get 2 times y, which is 1 upon 2. Here we have 2 times 1 upon 2 is equal to a times x. Here x is 2 and we have negative 5. On left hand side we have 1, 2 times a minus 5. It is a simple equation. 2 times a is 2a, and on transposing this negative 5 to left hand side, we get 1 plus 6. It is equal to, on transposing this negative 5, we get 1 plus 5 and it is equal to 2a is equal to 6 and a is 3. Therefore, the value of a is 3 and this completes our solution. Let's move to the next question. Here circumference of the base of right circular cone is 44 centimeters and its slant height is 10 centimeters. We have to find the curved surface area of this cone. Let's work out the problem. And here we are given a cone and the circumference of this base circle is 44 centimeters. If we take r is the radius of this base circle, then we have circumference is 2 pi r, which is equal to 44 centimeters. Now let's substitute the value of pi, which is 22 upon 7, and find the radius. To find the radius, we transpose all these terms, that is 2 times 22 upon 7 to left hand side. We get 44 divided by 2 times 22 upon 7. Here we have 7 on numerator. That is, the value of radius is 7 centimeters. We have to find out the curved surface area of this cone. To find this value, we are given the slant height. Here we have the slant height and it is equal to 10 centimeters. And we know that curved surface area of a cone is the product of pi r l. Here we have the value of pi, which is 22 upon 7, and radius is 7 centimeters, and we have slant height, which is 10 centimeters. On cancelling numerator and denominator 7, we get 22 times 10, which is 220 centimeters square. Therefore, the curved surface area of this cone is 220 centimeters square. And this completes our solution. Let's move to the next question. In this question, we are given two concentric circles with center O. A, B, C and D are the points of intersection of a line to these two circles. And here the length of AD is 12 centimeters and the length of BC is 8 centimeters, and we have to find AB and CD. Let's work out the problem. Here the length of line segment AD is 12 centimeters and BC is 8 centimeters. From the property of circle, if a perpendicular is dropped from center O to the chord BC, then the perpendicular is a bisector. That means the perpendicular divides the chord into two equal parts. Since OM is a perpendicular bisector of BC, we have BM is equal to MC, which is equal to half of BC. We are given BC, so we can find out BM and MC. Therefore, BM or MC is equal to half of 8 centimeters, which is 4 centimeters. Therefore, we obtain the length BM. Now we can find out the length AB. If we consider the another circle, that is the larger circle, here OM is also the perpendicular bisector of this AD, line segment AD. And OM is a perpendicular bisector of AD, we get AM is equal to MD and it is equal to half of AD. Here we are given the value of AD, therefore we get half of 12 centimeters, which is 6 centimeters. We obtain length of line segment AM and MD, which is 6 centimeters. By using these two, we can find out the length of AB and AC. Here we have AM, which is 6 centimeters, and here we have BM, which is 4 centimeters. Therefore, we get AB by removing BM from AM. Therefore, AB is equal to AM minus BM, and it is equal to 6 centimeters minus 4 centimeters, which is 2 centimeters. Similarly, we have to find CD also. We can find CD, which is obtained by removing MC from MD. MD minus MC gives CD, which is 6 centimeters minus 4 centimeters, and it is also equal to 2 centimeters. Therefore, we notice that AB is equal to CD and it is equal to 2 centimeters. This completes our solution. Let's move to the next question. Here we are given the height of a cone, which is 15 centimeters. If its volume is 1570 centimeter cube, we have to find the radius of base circle of the cone, and we have to use the value of pi, which is 3.14. Let's work out the problem. Here we have a cone and we can find its base radius. In this question, we are given height of cone. Let it be small h and it is equal to 15 centimeters. And we are also given volume, which is equal to 1570 centimeter cube. Since we don't know the base radius, we assume this be r centimeters, and we have height, which is h. We know that volume of a cone whose base radius is r and height is small h is 1/3 pi r square h, and it is equal to 1570. Let's work out it. Here we have to find small r, so we make it subject. Then we get r square is equal to 3 times 1570 divided by pi times h. Let's substitute their values. Here we have value of pi, which is 3.14, and height is 15 centimeters, and on numerator we have 3 times 1570. Here numerator and denominator 3 goes in 15 5 times, and on numerator we have 1570 and the product in denominator is 15.7, and on cancellation we get 100. Therefore the value of r square is 100. By applying square roots we get the value of r, which is 10, and it is in centimeters. So we have the radius of base circle is 10 centimeters. This completes our solution. Let's move to the next question. Here the diameter of a roller, which is 120 centimeters long, is 84 centimeters. It takes 500 complete revolutions to level a playground, and we have to find the cost of leveling the playground at the rate of 25 rupees per square meter. So let's work out the problem. Here we have a roller. Let us assume this is the roller and it is 120 centimeters long. That is, the length of roller is 120 centimeters and the diameter of the roller, and it is 84 centimeters. And diameter is equal to 2 times its radius, and it is equal to 84 centimeters. Therefore the radius of this roller is 42 centimeters. So using these two we can find the cost. To find the cost, we have given that the roller takes 500 complete revolutions to level a playground. We know that for one complete revolution of the roller, the surface area covered by the roller is curved surface area of this roller. And to calculate the area covered by this roller to level the playground, we take 500 revolutions. So in 500 revolutions, the area covered by this roller is 500 times its curved surface area. We have the curved surface area. Since the roller is in the form of cylinder, its curved surface area is circumference of this circle, which is 2 pi r, times its height, which is 120 centimeters. So here we have the area covered by the roller in 500 revolutions is 500 times 2 pi r h. Let's substitute their values, and we have given the value of pi, which is 22 upon 7, and the radius we got is 42 centimeters, and its height is 120 centimeters long, which becomes its height. Therefore in numerator and denominator we have 7 common factors. So 7 goes in 42 6 times. By multiplying the numerator we get 1548 into 10 power of 4 centimeter square. Here centimeter times centimeter is centimeter square. If you look at the question, we are given the rate of leveling the ground per square meter is 25 rupees. Here we are given the cost in meters, that is square meters. So we convert centimeter square into square meters, and then we got the area in meter square, which is 1548 meter square. It is because 1 meter is 100 centimeters. We have the cost of leveling 1 square centimeter. We have the cost of leveling 1 square meter is 25 rupees. Now we find the cost of leveling the ground. Here it is equal to 25 rupees into the total surface area covered by the roller, which is 1548 meter square, and it is equal to 39,600. And this completes our solution. Let's move to the next question. In this question we are given a figure. Here we have a circle with center O, and A, B, C are 3 points lying on the circumference of this circle, and angle BOC is 30 degrees and angle AOB is 60 degrees. If D is any point other than the arc ABC, we have to find out angle ADC. If you look at the figure, we get ABC is a arc and it subtends two angles. It subtends angle at the center, that is angle AOC, and at point D, that is angle ADC. Here we have to find ADC. How we find it? We know that angle subtended by the arc at the center of the circle is equal to 2 times the angle subtended by the same arc on the remaining part of the circle. So let's solve the problem. Here we have angle AOB, which is 60 degrees, and angle BOC, which is 30 degrees. So by combining these two, we get angle AOC, that is the angle subtended by the arc at the center, and it is equal to sum of 60 and 30, that is 90 degrees. And here we know that the angle subtended by the arc at the center, which is angle AOC, is twice the angle subtended by the same arc on the remaining part of the circle, that is angle ADC. So here by using this equation we get angle ADC, which is half angle AOC. We have got angle AOC, which is 90 degrees. Therefore angle ADC is 45 degrees. And this completes our solution. Let's move to the next question. Here we have to show that each angle of a rectangle is right angle. So let's work out the problem. And according to the problem, we take ABCD is a rectangle. And we have to prove that in this rectangle, each angle is 90 degrees. If ABCD is a rectangle, then ABCD is also a parallelogram. That is, every rectangle is a parallelogram. And we know that in a parallelogram, two sides are parallel. Here also in the rectangle, two sides are parallel. And from the properties of parallelogram, we have sum of co-interior angles is 180 degrees. That is, they are supplementary. And we take A and B or C and D, any two interior angles, their sum must be 180. Therefore, angle A plus angle B is 180 degrees. And in this question, we have given that A is the, and here we have any angle is right angle. That means we take angle A is right angle. Therefore, we get 90 degrees plus angle B is 180 degrees, which is equal to angle B is 180 degrees. Therefore, we get angle A and angle B is equal to 190 degrees. Similarly, we can prove angle C and angle D is 90 degrees. How we can prove this? Because C and D are also co-interior angles. Their sum must be 180 degrees. So here we have, in any rectangle, each angle is a right angle. Let's move to the next question. In this question, we have to show that the points A 1, 2, B -1, -16, C 0, -7 lie on the graph of the linear equation y is equal to 9x minus 7. So let's work out the problem. Here we take the given equation y is equal to 9x minus 7. And we are given the 3 points. First of all, we take x A 1, 2. To show that A lies on this linear equation, we have to take the x coordinate and find its corresponding y coordinate. Let us substitute the value of x in this equation. We get y is equal to 9 times 1 minus 7, and it is equal to 2. Therefore, 1, 2 is the solution of this equation, and we say that the point A 1, 2 lie on the graph of y is equal to 9x minus 7. Let's take the next point. Here we have B -1, -16. Here its x coordinate is -1 and corresponding y coordinate is obtained by substituting the value of x, which is -1, and we have -1 plus -7, which is -16. Therefore, we can say that -1, -16 is the solution, and it lies on the graph of linear equation y is equal to 9x minus 7. Similarly, we have third point, which is 0, -7. Let's take its x coordinate, that is 0, and substitute it in the equation y is equal to 9x minus 7. We have y is equal to 9 times 0 minus 7, which is equal to -7. Therefore, 0, -7 also lies. Therefore, 0, -7 lies on the graph of y is equal to 9x minus 7. From these three statements, we can say that A, B, C are the 3 points which lie on the graph of the linear equation y is equal to 9x minus 7. And this completes our solution.